In this project, what we will do is that we will create two publishers and one subscriber. Unlike the previous project that we did, in which we created one publisher and one subscriber, that was very simple. But in this one, the aim is to create two publishers and one subscriber. It's more or less the same project, but there are a lot of conceptual points involved in this project because the publishers that we will be creating, they will be differently coded. By differently coded, I mean is that we will have different files for each publisher. Okay, and then we will use one subscriber to call both of the publishers. So this is a really interesting project, and so far this is my favorite project that I did in ROS 2, and now I want to share how to do stepwise programming of two publishers and one subscriber in ROS 2. The idea is to create two publisher, and I will be relating it to some real-time project. For example, there is a kid and he's playing with his toy drone and he wants to fly that drone, right? So he places the drone on the ground. So initially that drone has zero height because it is on the ground and it is not moving around here and there. So its velocity is also zero. There are many parameters involved in robotics, and it can be like roll angle, pitch angle, yaw angle, and many other stuff, battery charging, discharging. But we will not talk about that because I want to keep this simple. So if someone is not from robotics field, he can also do this programming. So the point is, I will create two publishers. One will be for height, another one will be for the velocity of the drone. Just to give you some practical significance and how to relate this project with some practical project. So let's go. First step is to install the package we want to create, right? But before that, let's see if the package already exists in my directory. So I will open the folder where we put all the packages. So that folder is src. In order to open this package, the command is really simple. You simply write cd and anything you write after this, it will open that folder. If it does not exist, then you have to create the directory for that, and I have uploaded one separate video to tell you how to create a directory or how to create a package. You can also go and watch that video if you want to learn it in more detail. Now we have opened this folder src, and we want to see which packages do we have. So when I write ls and press enter, we will see we have basic football, basic ROS, quad rotor basics. I installed these packages previously since I have been learning ROS 2. You may have no packages over here, or you might have more than 3 packages over here. So don't worry. What we will do is that we will create our own package, and we will use that package for creating publisher and subscriber. So in this video, you will also learn how to create a package. Actually, it is just one command for creating a package, and that is really easy and simple. So the first step for creating a package is that you have to be in this folder of src. So if you are in any other folder, what you need to do is that you need to write this cd command, ROS2 workspace, and src. You will be in that folder. Now in this folder, we will always install our packages. Okay, whenever we have to install a package, we will be installing it in src folder, and this is what I recommend to you, to use this src folder, because most of the ROS developers, they use this structure or this directory for programming. So if in future you want to go to their online forums and want to have a discussion with them, or if you want to get some suggestions from them, so they will look at your code according to their own concept. So they use this src folder, and most of the developers use it. So I also recommend you to use this src folder. Now, once you enter this folder, what you need to do is that you simply have to write this command of creating the package. So what is the command for that? We will write ROS2, right? Package, create, and then build type. We have to define this, right? And AMENT Python, because we want to create our publishers and subscribers in Python. And if you are a beginner, I suggest you to use Python instead of C language. So ROS2 package create build type AMENT Python. After that, we have to name the package. So you can name it anything you want, whatever you want to do. You can name it like drone project. You can name it as toy drone, whatever you want. To use a professional word, I will name it as drone telemetry. Okay, this will create our package with the name drone telemetry. So when I press enter, it will create the package. Now to see if we have been successful, I will write ls and it will list all the packages in this folder. So you can see over here, the package drone telemetry has been created. Previously, it did not exist. You can see over here, we had 3 packages only. Now we have 4 packages. Now this next point is very important to remember. Whenever you add or delete a package, what you have to do is that you have to refresh the environment or libraries for the programming. There is a lot of concept and explanation involved behind this next command, but just to keep it simple and so you can understand and remember it. So I will tell you that this next command is used to refresh the libraries because we have created a new package. So how do we do that? We will go to the main folder or main workspace, cd this /ros2 workspace, and we will write colcon build. So it will build all the libraries again, and you can see 4 packages finished because previously we had 3 packages and now I added 1 more. So it has finished refreshing that. Next, what we need to do is that we need to use this command source install setup.bash. So these 2 commands are very important to remember because most of the time you will be refreshing your libraries. So now I will see what is existing in this folder. So ls, you can see we have build install log and src folder, and I will go back to this src folder to confirm if my package is still over there. So you can see drone telemetry package is over there. We have created our package. Next step is to create the publisher. That is the main goal of this project or this video. So we will go to the package folder. Okay, so if you are here, so that's good. You just have to enter this drone telemetry folder. In case if you are in some another folder, so you need to write this full command cd ros2 workspace src, and this is our package. Okay. So what do we have inside this folder? Let's see. So you can see we have another folder inside that folder, and it has the same name, drone telemetry, and we have some files in XML, resource, setup, Python extension, and test. So we have entered the package folder, but we need to enter Python module folder where we will create our package. So don't get confused with this. Drone telemetry, the first one represents the package. The second one, it represents the Python module or the folder where we will do our programming for publishers and subscriber. So don't get confused in this, okay? As soon as I write this, it will take me to that folder, and I want to see what is inside this folder. So I will simply write ls, and it will show me that there is one Python file for initialization. So now there is no publisher, no subscriber in this folder. So in this next step, we will learn how to create a publisher. In order to create a publisher, the command is very simple. It's just one word, and it will create a publisher with that name. Okay, so the command is nano, and after that you can name the publisher as you like. So let's call it drone telemetry altitude. I want to keep it simple or smaller, so I will only write drone underscore altitude. .py. This .py is very important because it will tell ROS2 that this is a Python extension. So it will create and open this file of drone altitude. Okay, you can see we have created this file drone altitude.python. Now, next step is very important. This is very important. In my previous videos, I gave you the codes for these publishers, and you could simply copy paste it and see if your projects were working. But another important point of this video is to tell you how to do the programming. Okay, because you will be using this throughout your ROS2 projects. It can be any project, your school, college, university. You could be doing some job. You will be doing this programming. So it is much better and recommended to understand the concept behind the programming in this file. It is very easy. There are just 4 steps. Okay, if you understand all these 4 steps, you will be able to do programming in these files for your most of the projects. First step is very simple. You have to import libraries. Sorry if my spellings are incorrect. So how do we do that? First step is to write this command import. I told you import libraries, right? So import RCLPY. Yeah. This is the first command, and what we need is to import this RCLPY. Now from this RCLPY, I will import node. Okay. One key point I want you to remember is that this N should be capital. Okay. When I was learning ROS, I used to make this mistake a lot of times, so I suggest you to be careful about this. And then again from std underscore messages, not message, import string. I will explain it to you why we wrote this third command of message. The reason is when we talk about the drone velocity or drone height, so it is some number, right? So if you have done some programming, you will know there are different formats of number. You can name it, you can create these numbers using float, 64, float, 32, strings, and many other. We will be using string over here for our messages. Okay, now this was the first step, really easy, right? In the second step of programming, what we need to do is that we need to define class. Okay, we will define the class. So it's again very easy. Class altitude publisher. Let's not add these underscores. Okay, class altitude publisher. This is our second stage of the project. Now in the third step is the main code. Actually main code will be more easier because you have to just call this altitude publisher, this one, and run your simulation, how to stop it and how to shut down your code. And at the end, the last part of this code is simply name this. If name is equal to main, okay, so main, this is the last part. So you can see we just have 4 parts of these codes, right? Now we will fill these parts. First one we have already done. Now in the class, what we need to do is that we need to initialize our nodes and topics, right? So how do we do that? It's very easy. Define or definition, initialize self. Okay, that's it, right? And next one is we have to define a callback. So we will have a timer callback over here because we want the height and velocity to change with time, and it will be changing with time, so we have to call back this timer. You will see in the next step how do we do that. Once we initialize this code, next step is very easy. Self.publisher, we are working with publisher, right? Self.publisher, because we have written self over here, right? So self.publisher, this should be equal to self.create publisher, create publisher, right? Similarly, in this one, in timer callback, what we need to do is that self.timer is equal to self.create timer. It's easy, right? Nothing fancy, very easy. Now we need to fill these brackets too. So how do we do that? Create a publisher, but we need to define the formats. So how do we do that? It should be string. The message should be string. I want to name it. So let's call it altitude, right? Because I'm making this altitude publisher, right? Altitude, sorry, I made a mistake. This should be over here, altitude, right? And then the next one should be, it's again a typing mistake, sorry for that. Next one should be 10. You can write 500 or whatever you want to write over here in place of 10, because this is the number of messages that will be stored in the node, and that's how publisher and subscriber will interact with each other. So it can store 10 values, for example 1 meter, 2 meter, 3, and up to 10 values. You can write any value over here that you want. So it's done. Now coming back to self.timer. So once again, we need to define this, but for timer it is much more easy, because for timer we want it to change with every second, right? And then the next command is self.timer back. Okay, so this is actually a slight mistake I made over here. This should not be over here, and I will explain it to you. This timer would be in initialization, because we want to initialize our project, right? So that point should be over here, def timer all back. And so I just made a small mistake, because when I create a timer, I have to call back that timer from this one. So that's how I realized that it should be in the initialized portion. Now, next step is actually very easy. And before going to timer callback, I want to fill more information in this initialization so we don't get confused. Now we have created self.timer, we have created self.publisher. I also want to initialize the height of drone. We know that drone height cannot be negative. It should be 0 or above that. So self.altitude is equal to 0. Now, next step is to write the code for a timer callback. Once again, it is very easy. Message is, we know this, right? And what is message data? So here, whatever we write over here will be displayed to our subscriber. So once again, you can write anything you want over here. I will write altitude, of drone, whatever you want to write over here. This message will be displayed as it is. And then what will be the value of it? So it should be read from this self.altitude. Okay. and then of course it should be in meters. So this is the code for message.data, and then everything is very easy. Self.publisher that we created in initialization. Okay, so you have to be careful with spellings. So it should publish. Self.publisher we created over here, right? So it should publish the message, right? And after that, self.getLogger, it should have information of message.data. Okay, and next is to increase the height, altitude plus equal to 1. So this last code will change the height of the drone. So this was about initialization. Let me see if I missed anything. Yes, I missed one key point. When we write this definition of or define initialization of self, we need to super initialize as well. So super dot init, and then we will write, let's say, zone altitude. Okay, so second part of the code is done. Import libraries was the first one, class was the second one. This is a bit technical, but it's very easy once you memorize it, because what you need to do is that first you need to create a publisher, then you need to create a timer. When you create a publisher, you have to define the format of the message. So we had imported string over here, so we will write string, then name the topic, that is altitude, and store the information 10. Okay, we want to save 10 messages at a time. In timer, the simulation or program should run for every second, so 1.0, and it should call this timer callback, which will be defined later on. This command was for initializing the height of the drone. Now in timer callback, we defined a message. You can once again name it anything you want. You can write full message word over here, but to keep it simple, I defined this message is equal to string. Okay, because I want to publish this information, so that's why I had to define this. And in message data, I have to write this command. Next one is very easy, and you have to use it every time you do programming in Python or ROS2. That is self-publisher publish this message. Okay, so this message will actually read this data and then publish it. And after that, we have to write this command for logger. Okay, now coming to the main code is actually much more simple and easy than the previous part. So what we need to do here is that define main arguments args is equal to none. Okay, after that, what we need to do is that we have to initialize x is equal to args. So this command actually tells ROS2 that wake up, we have a code and we want to perform some programming. Next is node. So what is the title of our node? So you have to be very careful with spelling and all these case sensitive alphabets. So we have to write this exactly as it is. So node is actually altitude publisher. So we will write this over here, altitude publisher. That's it. Next, we want to run this code again and again. So rclpy.spin node. If in case we want to stop our program, so node.destroy. Sorry, not okay. It's all right. No, node.destroy node. Okay, because we told it this node should be destroyed, and this node is actually altitude publisher. And the next one is to shut down this code if needed. When we press Ctrl+C, it will stop the code, and that's it. So part 4 is already done. Main code is much more simple than this second part, where we create this class for the publisher. So once we have finalized this code, I hope that I have not made any mistakes. So we will see when we run this publisher. But the code is finalized for the publisher. After that, what we need to do is that we need to press Control and O, then press Enter, and then Control plus X. So our publisher is created. Let's see. So we can see here drone underscore altitude dot py is created. Py shows the extension name. Now I realized one point, so I don't want to get confused. So instead of writing drone altitude.py, let's rename this file. So we will also learn how to rename the file in ROS2 in the next step. I want to rename it to publisher. You can use it like this as well, no problem. But if we will have many publishers and many subscribers, so we will get confused. So just from the start, we should avoid that confusion by renaming this file. So how do we do that? It's just one command, mv, right, drone altitude dot py. I hope the command is okay and I don't mess up with the file. So mv drone altitude py, which is Python, and I want to name it, let's name it altitude publisher. Right, I want to add this word publisher to it so we don't get confused later on when we will have many publishers and many subscribers in the folder. So I will write the extension name as well and press enter. So let's see if the file has been renamed. So I will write ls and press enter. So you can see altitude underscore publisher.py file has been created, which was renamed from this drone underscore altitude.py. So congratulations, we have created our first publisher. Now, after creating the publisher, we need to actually do one more step, and then we will see if these publishers work or not. And after that, we will create the second publisher. So next step is to go back to the folder and open the setup file. You can see we don't have a setup file over here. It should be in the package. So ROS2 src. You can see once again, this does not exist over here. And the package name was drone telemetry, this one, right? So you can see we have this setup Python file. So we want to edit this file. This is already pre-programmed, so you don't have to worry about it. So how do we edit this file? We will simply write nano setup.py and it will open the file. So this is already pre-programmed, so you don't have to worry about that. Only thing that concerns us is that we have to edit this console script command over here. Okay, so how do we do that? It's actually very easy and very simple. We simply have to fill our publisher names over here. So what was the name of the publisher that we created just now? It was altitude publisher, right? Altitude. We will see if I make any mistake. We will see. Altitude publisher, that was the name. Okay, is equal to now drone telemetry. We named this package, right? Don't use the name of other packages because it will look for that package. So you have to be careful over here. Drone telemetry or the package name, and then altitude publisher again. Main. Okay, so we have created the publisher and also edited our setup Python file where it will be called. So how to save this? Control O, enter, Control X. Okay, so we have created our publisher file. Before running that, I told you we need to refresh our libraries. So it's very easy. Colcon build, right? Now it will refresh all the libraries and all the packages. So what we can do is that we can also do this packages, select drone telemetry. If I have written this command correctly, so it will only refresh this package of drone telemetry, and let's see. So you can see it is only updating that file. Okay, next step source install setup.bash. We have to do this because we edited this setup.python file, right? So it will update that file. So now our publisher is created. We have edited a setup Python file as well. So everything has been successful so far. Now we will run the publisher. We want to see if it works. If we have made any mistake, it will give us an error. Sorry, I received a call, so I had to pick up that. You may have heard the ringtone as well. So our publisher is created. Our setup file is also updated. Now we will run the code. So how do we do that? ROS2 run, and then package name. Package name is this one, and we want to run our publisher. I hope there is no mistake, and we will see if it works or not. So ROS2 run drone telemetry package, and then we have this publisher, and I will press enter. So I made some mistake over here, so we will debug that mistake right now. It also tell us the mistakes over here as well. So we can see console script. I think there is a mistake somewhere over here, altitude publisher. And then we have this node name altitude publisher. We will do this debugging right now. So you will also see what kind of a mistake we must avoid. So what I will do is that I will open the file that I created for publisher. Let's open that file, and for that I need to go to this folder, to workspace, src, zone. Once again I wrote capital T, so you should be careful about this, and then drone, then yes, so we have the Python publisher over here. If you simply want to read this file, so you can write cat. If you want to open this file and edit it, so you can write nano. So let's write cat and also learn this command as well. So altitude publisher.py, it will open the file over here. Actually, it will print it in the same window. So I made a mistake, I think somewhere here. Let's see. We imported the libraries, then we called this node string capital N capital S, okay. Then we have class altitude publisher, and then we have defined this initialization zone altitude. And after that, I've created this file. Then altitude is okay, self double dots. These double dots are very important. You have to be careful about that as well. I'm looking for the mistake. So classes no double dot div. Okay, I think this is the mistake. Yeah. So what we need to do is that now we will write nano altitude publisher.py. And we can see over here this initialization. We have added only one underscore over here, but if you look here, there are two underscores. We will add one more underscore over here, and we will see if there is any other mistake. So after modifying our file, I want to read it again. Sure.py. I want to see if it has been modified. Yes, it has been modified. Now we will go back to the main folder, ROS2, workspace, pull build. I just want to select this packages, select, because I don't want to mess with other files. So it will update that. Source install setup.bash. Okay, so now I will run this code and see if it works. ROS2 run package. So package name is drone telemetry, and then the file that we created. So altitude score publisher.python non-executables. So this is a new error for me. So let's see why I got this error. So, uh, okay, I think the mistake is this .py. The reason is I also saw this in the documents. The reason is that ROS2 directly does not run Python files. So we don't have to write .py over here. Only when we create subscribers or publisher, we have to write this extension name over there. The reason is that we want to create these extended files with these extension, so ROS2 can know these files have been created. But when running the code, we should not write this extension name. And now we will see if it works. I hope so, because I wrote a long code over here. So let's see. So once again, there is a mistake. Let's see. What is the mistake over here? We can see console scripts altitude publisher. Let me see. Yeah, I think the problem is in our setup file. Yes, it's here. I will directly open it instead of reading it. So we can see console script over here. The file looks okay to me. Altitude publisher is equal to drone telemetry altitude publisher dot main. This looks okay to me. I will see what else. Without editing, I will press Control X. Let's open our file again for the publisher that we created. I will directly open it so I can edit it as well. Import libraries, okay, class double underscore init double underscore super initialization double underscore init double under no, no, this should be double underscore. Control O, enter, Control X. Okay. So once again, now this file is created. So we will go to main folder, ROS2 workspace. I'm sure you have learned by now that we have to do this polygon whenever we do any modification in our files. Select and drone. Yes. Install setup.bash. Yes. ROS2 run drone tray altitude publisher without .py extension. And now we can see our drone is flying from 0 meter, 1 meter, 2 meters, 3 meters, and so on. Now this next concept is very important for you. We can actually read this information even without creating subscriber. So how do we do that? We will open another window and ROS2. I just want to see which nodes are operating. ROS2 node list, ROS2 list. You can see we have this topic altitude over here. How do we print this to topic? Echo, this echo command actually prints altitude as it is. So you will see it will obtain the information in real time. So 46 meter, because when we were writing these commands, drone had reached 46 meters and it has started to read the information in real time. Once again, I already did this, but I want to show you the lists, and because previously list was not shown, I don't know why. I did this again and it shows me now that we have a drone altitude node and we have this topic. And so altitude is already there. So ROS2 topic, you can also extract information from this info of altitude. Okay. So you can see we have one publisher and subscription count is 0. So when I read this information using echo command altitude, so you can see now that it is publishing the information. So If you open another window, you will see over here that ROS2 topic list, ROS2 topic echo, sorry, not echo. I want to show you this information. Now you will see subscription count will be 1 because this publisher count, this is the publisher we created, and subscription count is equal to 1 means that we are reading this information in real time using echo command. Okay, we have not created a subscriber yet. Now let's stop this over here and let's go back to this folder or this window. Now next step is to create the second publisher. That is the main aim of this project, that we will be creating 2 different publishers and 1 subscriber. So let's create our second publisher. It will be much more quicker than this because I don't have to explain all the codes to you, and because we already discussed that previously. So how do we create a publisher? I'm sure you already know this. To workspace src drone telemetry, that is the package, and drone telemetry, this is the module list. So it will show us the files in that folder. Nano, previously it was altitude publisher, now I will write it as velocity publisher. And now I have to tell this as a Python extension because it must know because, that this is a Python file. So it will create this Python file for us. Now we simply have to fill this file. I can copy paste it from the previous one and then edit it, but I suggest you that we should do proper coding over here for your own practice because this is very easy to do. And how do we do that? You simply have to import the libraries. I will be doing it much more quickly now. Okay, from this rclpy.node we must import node. Okay, and then we have to define this message format, import string. Now next step is to define the class. So class, let's say velocity publisher. You can name it anything, but you must remember when you call this one in the main part of the code node. Okay, next one is very easy. Define initialization self, right? And then the next one is define timer callback self. You will see why we do this. So in this second part, let's add these comments so we can know we are in this part. Now in initialization, we need super initialization. Be careful with these double underscores. Previously I made this mistake. Velocity publisher, let's name it velocity publisher. And by the way, when I was learning Python, it was recommended to use small alphabets. Okay, so I will also tell you that. I don't know the reason yet, but it was recommended to use small alphabets. We can use capital alphabets as well, no problem. So after that, in initialization, we have to create publisher, self.publisher. This should be equal to self.create publisher. Okay, and then we will be creating self.timer. This should be self.create timer, right? Similar to the previous code. Now we have to fill this. So how do we fill this? Publisher, we know it should be string, right? Because we are measuring the velocity of the drone. Then we have to name it. So let's call it velocity. Okay. And how much information do we want to save? 10. You can use 100, 5, 1, 2, 3, whatever you want. Okay. After that, we will go to self.timer. So this timer is actually easy. We want it to be after each second, and we will call this timer callback later on in this timer. Next step is to define the initial height, or sorry, similar to the initial height, we will also define the velocity because when drone is at the ground, it has no velocity. So how do we do that? self dot velocity is initially 0. Okay, now for this timer callback, it's easy. Message is equal to string, we know this. Sorry, I opened some other files. Okay, message is equal to string, we know this. We already imported this, right? What should be message data? You can write here f anything inside this double semicolons. I think this is semicolon, I don't know, inverted colons, what it is called, I don't know, but just you should know this. Velocity, and then we should call this file self velocity, which is initially 0, we defined up there, and outside this meter per second, that is units. Okay, next is self dot publisher. We define this up there, and it should publish the message. Okay, and then next is the self dot get logger. It should tell us the information of message dot data. Okay, self dot velocity should be incremented after each time. So this was the second part. Next part is actually the main code. They call it main code, but actually it is much more easy than the second part. What we do is that we define main arguments is equal to, I don't know if this args means arguments. I often say arguments, but I don't know if it is arguments. You can check that in the documents. But the key point is how to program it. So define main args is equal to none. So first of all, we have to tell ROS that wake up. We have a program running in the background. We have to call node. This node name should be same as this one, this class. Okay, no mistake in spellings, neither in alphabets, whether capital alphabet or small. Okay, next is keep running this node, so rclpy node, and after that we have to use this command to stop the code if needed. Destroy node, right? And then how to shut down this if in case we press Ctrl C. So this is the main part of the code. And last one is this more or less stays the same in every code so far we have done. Underscore, no mistake of single underscore. Previously we made this mistake. If double underscore name double underscore equal to main, so this should be main. So this is the second publisher. Control, after that Control O, enter, Control X. Okay, now we have created this publisher. Let's see if it is created. So we can see we have altitude publisher that we created previously, and now we have velocity publisher. Now we have to add this velocity publisher into the setup as well. So we will open that file, cd ROS2 workspace src, and then zone telemetry. It will be here. You can see setup.py. I will directly open this file, and you can see it is already pre-programmed and our previous publisher is already added over here. So altitude publisher is equal to drone telemetry and this X command. So we need to add this next publisher over here, drone. I hope that I have not made any typing mistakes this time. So package name dot velocity, which is the publisher name. Okay, so I hope there is no typing mistake. This should be comma. Yes, Control O, enter, Control X. We will go back to main folder, ROS2 workspace, con build packages, select. We want to select only this package. Okay, so it will target that only. Source install setup.bash because we modified this file. So now we will see if this works. But before that, even before running this code, what we can do is that we can see if these files are correctly built. So for that, the command is ROS2 package. I want to see executables of this package. Okay, drone telemetry. Yeah, I don't want to make any mistake. ROS2 package executables drone telemetry. So it shows me that we have altitude publisher, we have velocity publisher. So it is executable, but let's see if it is indeed executable. So we created velocity publisher. If there is no mistake, publish this. I hope so there is no mistake. We have made a mistake once again. And I think the mistake is that I used small n instead of capital N. This is what I think, but we will see. The mistake is in velocity publisher Python file. So let's open that file and see what mistake did we make. Not make, what mistake did we made or make? I don't know. English is not my first language. So let's see. So we will open that file, ROS2 workspace, src, zone telemetry, zone s. I want to open this velocity publisher dot py. So the problem was in the name of node, right? So we will see. I think the mistake is this one because I often make this mistake. I want it to be of capital letter and use small letter in the code. So I think this is the only mistake that we made. It should be capital one because if you see here, we have imported a capital uh, node over here, node with capital, and we saw there as well that it was pointing out to this mistake. You see, class velocity publisher node, error name node is not defined. Did you mean capital nod? So I think this was a mistake. And now what we need to do is that we need to go back to main folder, colon, build packages, select drone telemetry. By the way, instead of writing this whole command, you can press the arrow, the up arrow, and you can directly go to that command quickly. But I write this again and again to have more practice, and you can learn it much more. So it has done this. What I was talking about is that you see when I press this arrow, it takes me to all the previous commands, and I can simply do this. Now I can go back to this run command also and see if it works. So once again, we have a mistake over here. You see, it tells us that what mistake did we make. So I have written MAI instead of main somewhere. So let's open this folder. Instead of writing all this command, I will directly write this and then nano velocity.publisher. Somewhere I have written MAIN. By the way, I did not see if it was talking about setup file. Let's see, Control X. It is talking about velocity publisher line 33. Okay, there is drone telemetry velocity publisher. Okay, so it's in velocity publisher somewhere. I have written MAI. So MAI, we need to find that mistake. I think it should be here. It's not here. It's happening. So I checked the mistake already. So I will do the code again to show it to you. If you remember, we created this package ROS2 workspace src zone telemetry, and then we created a publisher over here. After creating the publisher, we edited this setup.py. You may have caught this mistake already, and I saw this, that instead of main, I wrote mai over here. So this should be main, right? So Control O, enter, Control X. Now go back to main folder, ROS2 workspace, build. It will build all the packages, and it takes more time. So that's why we can select that particular package as well. Source install setup.bash. So it has installed it. So now ROS2 run drone telemetry and velocity publisher. Did we write it with small letter? I don't know. Velocity publisher, the name of the file. So we can see here it is working. So now we have two publishers and two separate publishers. We can see over here, this is velocity publisher, and I can run this over here, the altitude publisher. So ROS2 run drone telemetry altitude publisher. So let's see if it works. So yeah, you can see 0, 1, 2, and it is publishing the information. Now, just for our information, tell me the nodes. So we have drone altitude, we have velocity publisher. These are the names we gave inside those Python code, okay? And ROS2 topic list. Now, you might be confused why we have this drone altitude over here and why velocity publisher name over here. So I want to focus first on that. So what we need to do is that we need to open this file ROS2 workspace src in drone telemetry, and then its folder again, which is Python module drone telemetry. Yes, we are in correct folder. So I want to show you cat. I just want to open it in same window so we can compare the code, and that cat velocity, sorry, .py. Okay, so let's scroll up there. We have node with name drone altitude and velocity publisher. So when I open this altitude publisher, you can see here I super initialized it with this name, drone altitude. So this is the name. And if I go to the velocity publisher, you can see I wrote velocity publisher over here. So you can name it anything you want, whatever you feel is best. So it will be shown to you in the list of nodes. Okay, so don't get confused with this. You can write drone velocity over here, and it will show you drone altitude and drone velocity in the node list. Write this again. So we can see drone altitude, drone and velocity publisher, ROS2 topic list. So it will show us the topics. Okay, so we have altitude, okay, and we have velocity because we have two publishers. So ROS2 topic echo altitude. So it will publish the altitude in real time. So the drone is already in the air, so it will show us values from that moment onwards. So you can see 139 meters. And in order to publish this velocity, let's go to this next window, ROS2 topic list. So velocity with small v, ROS2 topic echo velocity. So you can see it is flying with this speed. This is unrealistic speed, we know that, but this is just to give you an example. So in the first window, we have a velocity published. In the second window, we have a altitude published. Okay, once again, this is the message I wrote there, velocity, and here I wrote altitude of drone. I want to show you this over here. So this is the altitude publisher. So you can see the message altitude of drone. I wrote this. So that's why it is showing me altitude of drone. Okay. And in the velocity code, I simply wrote velocity. I could have written velocity of toy drone, velocity of drone, whatever I could have written here and it would have published same as that over here. In the third window, we have this altitude zone uh, written or read as it is in real time. And in the fourth window, we have velocity. So we have created two publishers, and both of them are different, and both of them have their own Python files. Next is the last part of this video, in which we will create our subscriber. The method of creating subscriber is same as publisher. It is same as that. Nothing changes, we will see, but we need to modify. The important concept is that we will be creating one subscriber instead of two subscribers. So we need to grab that concept. First step is, as always, we need to go to that folder, right? And how to do that, we know this already. ROS2 workspace src zone telemetry, and then Python, this Python module. We can see we have two publishers over here. Now we want to create a subscriber, so let's call it as nano and drone telemetry. Okay, telemetry and subscriber. I want to add this subscriber word so we don't get confused later on, and I named it as drone telemetry because it is grabbing or reading information of multiple states. Okay, so I just do not want to name it with something like altitude subscriber or velocity subscriber. It will be confusing. So because it is reading two states, so I wrote it as drone telemetry, and then we have to add this Python extension to it. So it will create the file. Now this will be much more easy for you because, as always, first step is to import the libraries, and from that library we need to import node, and then for publishing the message, std messages.message should be in string format. Now next step is to define the class, so let's name it as drone telemetry subscriber. Okay, I'm writing subscriber with it so we don't get confused, and this should be capital N. Remember that we made this mistake earlier. Next is define init, right? Initialize self, and after that we have to define. Now previously we defined timer callback, but here it will be slightly different. You will know why is that. Altitude callback. Okay, we'll have altitude callback because we want to call altitude and velocity, right? So velocity callback. Previously we used timer because we had to publish the information based on the time. With each incremental second we had to publish velocity and height. So this is the structure for the subscribe. So once again, in initialization, first step is super initialization. So super dot init, and let's name it as drone telemetry subscriber. Okay, now the next step, as always, self dot altitude subscriber, right? Previously we had different value over here. We had timer and we had publisher, but now we want self altitude subscriber is equal to self. Now this is very easy to remember. Create subscription. Previously we did self dot create publisher. Now we do create subscription. Okay, and the next one is self dot velocity subscriber is equal to self dot create subscription. Okay, now we have to fill these brackets. How do you fill it? We know this already from our previous code and experience. It should be string. Then we name it altitude. Okay. We have to be careful. I don't remember what did I name it here, but these names should be consistent with the publisher. Okay. We will see if I named it altitude or something else. So remember, this should be consistent with the publisher because subscriber will look for this information. Even if there is one extra alphabet, it will not be able to read it. Now, from after this step, altitude, we have to call back altitude, call back. Slight difference, but nothing fancy. And then this was 10, right? The only difference from previous code is that now we are calling the altitude, and we will do some programming for that. Now, the next one is velocity subscriber, same as this one, nothing fancy, very easy. String. This should be velocity. I think I named it velocity with capital previously, but we will see this. Velocity. Now, self dot velocity callback. This is the only difference between the publisher and subscriber for now. And then we write 10, and that's it. Okay. Now we have to code this because we need this in the initialization part. So how do we do that? It's once again, it is even more simple than the previous one. So altitude callback, it should be self and with message. Okay. And we simply write this self dot get logger dot info. Okay. And in this info, we will write f. This is much more direct than the previous one. Received altitude. Previously, we defined message is equal to string, then message dot data is equal to, and we defined our message like this. But this is much more direct than that. So you can follow either of them. Okay. So message dot data, and that's it. I hope there is no mistake. I really hope so. I just want to put this like this so I can read it much more easily. Now, velocity callback, once again, this should be self message. Previously, we defined message in the next step. So now I'm doing it directly over there. So self dot get logger dot info, right? And I have to fill this info with the message, which should be f double these inverted columns. I don't know how to pronounce. And then it should be received velocity. You can name it anything, velocity or real-time velocity. Let's name this differently. Instead of received velocity, real-time velocity of drone. Okay, I named it something like this. So this should be message dot data. That's it. Okay. Now coming to the next step, that is the main code. They say it is the main code, but I think this is very easy. Define main args is equal to none, double dot, rclpy init is equal to args node. This should be same name as we defined in the class up here. Drone telemetry subscriber. I want to see if I made any mistake. Drone telemetry subscriber. So this should be same as this one, drone telemetry subscriber. And then this one, it should spin. So this is like running the code. It would spin, no mistake of double E. And then node dot destroy node down. And then the last part. This is more of a standard command that we have been using and we will keep using in our codes. This if name is equal to main with these goes. Okay, so this should be main. The only concern I have is that did we use these names in our publisher or not? It's altitude and velocity. Okay, if we use that, I think there are not many mistakes in this subscriber. We imported the libraries, defined class, initialized, altitude callback, and velocity callback. So this is the important part of this video actually. Instead of creating two different subscribers, we created only one subscriber and it callbacks both of them. So altitude and velocity callback. Then main code and this one. After that, Control O, enter, Control X. Now we have created this subscriber. Its name is drone telemetry subscriber. So we have to add this in the setup file also. We will go to setup file, ROS2 workspace, src, drone telemetry, ls. So we have this setup Python over here. So nano setup.python, right? So we have to add our subscriber over here. So comma. So what was the name? Drone telemetry equal to this is the package name. So if your package name is different, you will write that name over here. Drone telemetry driver. I'm very careful about the alphabets and mistakes, so I hope there are no mistakes this time. Control O, enter, Control. Now, before proceeding, I just want to confirm the names of the topics that we have. So what I will do is that I will go back to this folder. I just want to confirm and don't mess up with our code. So altitude publisher by, so our topic name over here is altitude. So this should not be a mistake. Okay, because I also wrote altitude with small a, if I'm right, and then it was velocity, right? And here we have this with small v. So you see, I already figured out this mistake. So I need to go back. Even before doing that Kulkun stuff, I need to open my subscriber, drone, telemetry, driver, okay, this is a mistake, you see, even with one mistake. Okay, this is once again a mistake because this is a new file. This is not showing me any code. So I want to see if I'm in the same folder. So the name is drone telemetry nano drone telemetry. Previously, you see, I wrote extra e here, so it actually created this file and opened it for me, but I did not save it. So now drone telemetry driver.py. You can see we are in this file, and this v should be small. Okay, Control O, enter, Control X. Now we will go to our main folder, which is ROS2 workspace, and now I will do Kulkun build. Instead of building all packages, I will select drone telemetry only. So setup bash. It's done. ROS2 package executable. I want to see executable, which is showing me both of the publishers and subscriber. You can see altitude publisher, velocity publisher, and drone telemetry subscriber. So we have done Colcon. We have also installed the setup again. So ROS2 run drone telemetry. This is the package name. Altitude. So it is publishing our height. But our goal is to check subscriber, right? So I will go to this new window, ROS2 run drone telemetry. We created this subscriber with this name. So you can name it anything, okay? Drone telemetry subscriber. So you can see the spelling was incorrect. I hope it is correct and there are no mistakes. There is a mistake again. I want to see what mistake. Okay, this after define, I have not added double dot over here. I already figured this out. So we need to go to this folder, ROS2 workspace src drone telemetry drone, and then nano telemetry subscriber.py. So you can see after each definition def, I added double dots, but right over here, I forgot to add this. Let's see if I missed it in the main. No. Okay. So Control O, Enter, Control X, CD. Instead of this, I will stop this one. Directly use this command cd ROS2 folder. Colcon build this package. I'm just using the above arrow to go to these commands. So executables, yes. So now I will run this altitude publisher. Altitude publisher is working. Our main concern is this subscriber. So once again, there is some mistake. I don't know what is the mistake here. Line 33 in the module. Error. Function object has no attribute info. So let's open code that we wrote. Drone telemetry driver.py. So let's see what mistake did we make. And I think yes, we figured out. This is the mistake. You can see we already wrote it over here, but did not write over here. So Control O, Enter, Control X. So instead of once again writing all these commands, I will directly use the above arrow to build the packages, then source install setup bash, and then run this altitude publisher. I want to run this publisher because subscriber will only read this information when publisher will be sending some information. So let's clear this window and then run ROS2 run drone telemetry and then the subscriber. So you can see it is reading the information of altitude in real time. So that's why it starts from 16 meters. Now, the main part of this video is to explain the concept. Now I will run the second publisher. Here I am running the altitude publisher, right? So I want to run the second publisher and see if the subscriber is reading information from both of them. So ROS2 run drone telemetry velocity publisher. So we have velocity information now. We have altitude information now. So let's see. So you can see over here, it reads both information in real time. You can see real time velocity of drone. You know, I wrote this message over there. So velocity is 13 meters per second, and it is reading actually both of the publisher. Now, this video is a bit longer than expected because we did some debugging as well. And that is good, actually. We saw that even small mistakes like if you don't write double dot instead of capital N in node, if you write small n, these kind of silly mistakes lead to these errors and we will not be able to run our code. And we did debugging in publisher as well as in subscriber. And the key part was that we are running both of the publisher at the same time. We can see over here, and using only one subscriber to read the information, and it is reading the information. We can open this third window to see our nodes in the topics. So you can see we have drawn altitude, we have drawn telemetry subscriber, velocity publisher. Okay, so don't get confused with this once again, because this is the name I used in the velocity publisher. Okay, and in altitude publisher I used this name, so I can write any name over here and it will be shown to me in this window. Next is the list of topics. So ROS2 topic list, it will show us that we have altitude, we have velocity. These are the topics, right? These are running in the background. We have altitude, we have velocity. And then we can do this info of altitude. So you can see we have one publisher count and we have one subscription count. Publisher count is because altitude information is sent over here. And we have subscription count equal to 1. That means our subscriber is also reading it. So if in case I do this echo for altitude, so this will also read the altitude in real time, right? So you will see it will read the height in real time. So now instead of subscription count equal to 1, what do we think we will have? ROS2 topic list, ROS2 topic info. Now altitude is read from a subscriber and also using the echo command. So what do you think we will have in here? Publisher count will be 1. Subscription count will be 1 or 2. What do you think? Answer it to yourself and then we will confirm your answer. The answer is 2, because echo command is reading it in real time, and also subscriber that we created is also reading it in real time. So this was the main concept that we wanted to learn in this video and do all of this programming step by step. And I hope that it helped you and you can create many more publishers as you like. For the example of drone, I used velocity and height, but drone also has these angles, rolling angle, pitching angle, and we can also monitor battery. So the problem is, if we create publisher for each one of them, then we have to do a lot of programming and create so many publishers. So that is actually more tedious task. So in the next video, we will find a solution for that. That how can we save all these publishers in just one message or in one file and then read it using subscriber. So stay in tuned and stay with me and we will learn this together. One more thing, I have been learning this ROS2 for past maybe 1 or 2 weeks, and I have reached this point. So I believe you can also reach this point and much more quickly, because I just gave it maybe 2 or 3 hours per day, and that is like 3 or 4 days per week. So I reached this point. If you are more consistent and spend more time on it, you can learn even better. And the mistakes that I have been making, it's obvious that I'm a learner. So if I have made any mistakes or if you have any suggestions, please leave it in the comment for me so I can learn from you as well. And that's all for this video. And thank you. Have a nice day.